Okay, so let's take a look at example 4. Okay, one challenge in this question is reading it and understanding it, right? So you've got a current carrying a wire of 100 amps due west, and it's suspended between two towers that are 50 meters apart. The lines of force of the Earth's magnetic field are uniform there and enter the ground in a northerly direction at an angle of 40 degrees with the horizontal. Okay, so this is a 3-vector kind of problem. So here's the current. This thing is 100 amps, and this wire is 50 meters long. This is going due west. All right, and now this is coming down into the ground at an angle of 40 degrees. So now this is west. So if I turn this kind of sideways like that, and I have the current going away from me. So now here's this wire. The magnetic field is coming down this way. And if this is north and this is south, right? Because if you have this, as they say, never eat soggy waffles. And so if north is this way, that means west is that way and south is that way, right? And then coming out of the page is east. But this is what's happening here. And this angle is 40 degrees. Okay, and so IL cross B is going to be 100 amps, that's I. L is negative 50 meters I. Okay, so I'm treating east and west as my x-axis, all right? And so that means that north and south is going to be my, let's see, yeah, north and south is going to be my y-axis, and up is going to be positive on the z-axis. Okay, so how is this pointing now? B is going to be 5 times 10 to the negative fifth times cosine of 40 j, right? Because that's this component of this thing. That's the j. Minus 5 times 10 to the negative fifth sine of 40 k. That's going to be this, kind of going down. Okay. Okay. And so now, you know, when I do this, what I end up with is this cross product. So this is 100 out front. Let me erase this, create a little more space. So 100 times, so this is 50, 50, this is 3.8 times 10 to the negative fifth, negative 3.2 times 10 to the negative fifth, etc. And so now when I do my cross product, what we end up with is that the force is negative 0.16 J minus 0.19 K newtons. And so if we find the, what are we looking for here? So if we find the, all right, we multiply these using the Pythagorean theorem and do inverse tangent. All right, notice this is in J and K. There's no east-west here. So the force on this thing is just in the up and down, right? So a little bit down, and then also a little bit south, right? And so this is going to be 0.25 newtons at an angle of negative 130 degrees. So that's if we're looking at this from the side, right? Like this. North is over here, here's up, down. So it should be pointing down a little bit, kind of that way, right? Because it's negative J and negative K.